So Bayes classification. So last class example. So we have 4 documents here. Then one test set document D5. Document D5, which we have to determine whether it is China class or not China class. So first we need to find prior probabilities along with the conditional probabilities. Prior probabilities, like you can see the formula from here. So NC by N. So what is N? N is the total number of documents, and C is the number of documents in class C. C in the sense whether it is class 1 or class 2. Here our class 1 is China class and class 2 is not China class. Then conditional probabilities. So conditional probabilities also we are using the Laplace smoothing here. So get one Laplace smoothing. So with this formula, we will be finding the conditional probabilities for all the terms in the document. So prior probability 1, this is for China class. Prior probability for China class. So it is 3 by 4. So 3 by 4, your number of documents is 4. And 3 for Chinese. 3 for China class. So there are 3 China classes. 3 divided by 4. And for not China class, we have 1 class belonging to no class. So 1 divided by 4. Then conditional probabilities here for all the terms. First for Chinese, you have to find in China class. So this 5 plus 1, 8 plus 6. So what is 5 here? Number of terms, 1, 2, 3, 4, and 5. So 3 Chinese are there in these 3 documents. So we are finding only for China class. Yes class. So 1, 2, 3, 4, and 5. So 5 plus 1. So 1 is from this one. Laplace putting at 1. Again in the denominator, 8 plus 6. So 8 is the document length where you have to count all the terms in the collection with China class. So 1, 2, 3, 4, 5, 6, 7, and 8. So document length for China class is 8 plus 6. 6 is our number of unique terms in the vocabulary. So in the vocabulary, we have 6 unique terms. So that 6 here, we are going to add along with 8. So 5 plus 1 divided by 8 plus 6, which we get 3 by 7. Similarly, for all the terms, we need to find conditional probabilities. Then after finding the conditional probabilities, you have to calculate the final probability for D5, so which is unlabeled class initially. So D5 in China class, D5 in not China class. So multiply the prior probability along with you have to multiply prior probabilities along with your conditional probabilities. Then we got some probability value here. For D5 in China class, it is 0.0003. Again, for D5 in North China class, it is 0.0001. So which one has a higher probability? D5 in China class has a higher probability. So D5 has higher chances of belonging to China class, since the probability is greater than the probability we got in North China class. So D5, the classifier will assign the test document D5 to C, which is China class. Okay. So the reason for this classification is that after finding the probability, we are going to check which particular probability, that is China, D5 in China class has a higher probability, or D5 in North China class has a higher probability. We will be doing a comparison in the probability values. Then we will assign the test document to the higher probability value. So according to our example, D5 belongs to China class. One second. So the screen is gone. Just give me 5 minutes. Let me restart it. Okay, so you can see here. Uh, so we have already calculated the probabilities and we got the probability values here, and also the classifier assigns that is document D5 to the China class. Now we will be seeing the performance evaluation. Performance evaluation here. So this is evaluating the classification. So classification is normal. Evaluation is normally done on the test data. So some performance measures are precision, recall, F1, and classification accuracy. So these are some measures which we can evaluate for the particular classification method. And for this, we may construct a confusion matrix. So this is one example given for confusion matrix construction. So for each pair of classes, how many documents from C1 were incorrectly assigned to C2? So for this, you can check out this table. So we have true positives, we have false positives, we have false negatives, and true negatives. So from this, we will be calculating precision, we will be calculating recall using the formulas, and also we will be finding F1 score. So now for this, let me share another slide, which there is some calculation. So performance evaluation. One example is given here, the predicted class, actual class. So this is normally the confusion matrix which we use to determine the performance of a classifier. So spam class, not spam class, and again spam class, not spam class. So true positives, there are 45. That is, in actual class, it is spam class, and also when it is predicted, we got a spam class. So that is 45. And again for spam class in actual, and it is predicted as not spam class, it is false negatives. So which we have 20 documents. And again, in actual it is not spam class, and predicted as spam class, we have 5. This is called false positives. And finally, we have in actual class, it is not spam class, and also it is predicted as not spam class, which is true negatives. So we have 30 here. Then calculation will be done. So sensitivity you can calculate, accuracy you can calculate, precision you can calculate, and also negative predictive value you can calculate. So all these parameters, these are performance measures which we use to evaluate for classification. An explanation here, true positive is like we can just go through, this is the number of correct predictions, and false positive is number of incorrect predictions, false negative, and false positive, it is a number of incorrect predictions. Then an example is positive, so which means negative class incorrectly identified as positive. So which I have just explained now here. Similarly, we have true negative. So this is a number of correct predictions. Then an example is negative, which means negative class correctly identified as negative class. That is true negative. So it is given here, true negative, false positive, true positive, and false negative. So using this table, you can find out all these parameters, performance measures. So calculation is shown here for sensitivity also, taking out the values from the table here. So 45 true positive, 20, 5 and 30. So these values we are substituting in the formula and we are getting the values like this for sensitivity, for specificity, precision, and accuracy. So we got, according to this example, an accuracy of 75%. Then F1 score. So with this we can calculate. And another example is given here. So this example, the same example which here. So the same example, we are using another data. So this data is given here. So from this we can calculate other performance parameters like misclassification rate, then false positive rate, then prevalence also we can calculate. Okay, so next one, this is about performance evaluation. Then one is, we have one more model remaining, that is Bernoulli's model. So we will see Bernoulli's model calculation. So you can check it out from here, performance parameters values. So it's already you have ideas about this. So this next model, Bernoulli's model. Let me say this. So Bernoulli's model. This is an alternative model, and equivalent to binary independence model also. Here, like how we use in binary document incidence matrix, one and zeros, we are also using ones and zeros here, because Bernoulli's model, they are similar with a binary independence model. So binary, we already know it is zeros and ones. So this indicator will use 1 for indicating the presence of the term and 0 for indicating the absence of the term. So while classifying this case, we use binary occurrence information and ignoring the number of occurrences, whereas a multinomial model keeps track of multiple occurrences. So we will see directly the example. The same example for China class and North China class, we can calculate using Bernoulli's model. So let me show you.
Ma'am.
Yes,
Hello,
yes.
ma'am. Just one thing. The previous slide that you had shown where there was true positive, true negative, those things, we do not have that slide in our classroom, so please do send that afterwards.
Okay, okay, I'll send you. So that performance evaluation, I haven't sent you.
Yes, ma'am, it's not there. So,
Okay, 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 I'll send you that one. Okay, so after the class, I'll send you that performance evaluation material also. Okay. Okay, now, what about this one? Bernoulli's model, it is already with you.
Yes,
yes,
ma'am.
ma'am, that
Okay, okay, fine. Okay, we will see now Bernoulli's model. This is also, as I told you, similar with the previous, but little bit different here. Okay, so let us see what is the difference in Bernoulli's model and Bayes' model. So now in Bernoulli's model, as I told you, it is similar with binary independence model. So binary, it takes zeros and ones. Okay. So the same example, I have written it again here. So data for parameter estimation. So what's in the document? We have 4 documents, document 1, 2, 3, and document 4. And similarly, like the previous one, we are going to find about D5. So D5, to which document it belongs, whether it is in C class or not C class. So C stands for China. So yes class, no class. We have 3 yes classes and we have 1 no classes. The same example, okay? Then we are going to apply Bernoulli's model and we will be estimating like prior probability, and also conditional probability, like how we do in our Bayes classification. In here, you can see the estimates for prior probability. It is same 3 by 4. As you know, we have 3 classes of China class and we have 4 documents, so 3 by 4. Similarly, for North China class, we have 1 class for North China class and 4 documents in total. So we have 1 by 4 here. So up to this, prior estimation is same. Now for conditional probabilities, it is different. So in conditional probabilities, we have in the numerator 3 plus 1 divided by 3 plus 2. So you take here the denominators 3 plus 2 and 1 plus 2. These are the 3 documents in C. So we have 3 documents in C means yes class. So we have 3 yes classes, right? So since we have 3 yes classes, it is 3 here. Okay. So there are 3 documents in C class and 1 document in North China class. So 1 is for North China class and 3 is for 3 China classes. And the constant B is 2 because there are 2 cases to consider for each term. As I told you, it takes the similarity of binary independence model. It will be having 2 conditions. Either if the particular term is present, it is 1. If it is not present, it is 0. So we have 2 cases to consider for each term: occurrences and non-occurrences of the term. So our B value will be 2 here. So this 2, our B value will be 2, our B value will be 2. Okay. That's why the denominators, once again, let me tell you, we have 2 cases of denominators in the example here. One is 3 plus 2 and one is 1 plus 2. So 3 is because we have 3 documents in C. C is yes class. So there are 3 yes classes. That's why 3 here. And again, on the other side, 1. So 1 because we have 1 document in North China class. That is in no class, we have only 1 no class. So 1 here. Then this 2. This 2 is the constant value B. The constant value B, we have 2 cases to consider because since it takes the binary independence model, the condition is either occurrences of the term or non-occurrences of the term. So 2 here. So 3 plus 2 and 1 plus 2. Now, same this one for Chinese. We have in the China class, we have 3. This value is 1, 2, 3. So where is it? Okay, so the 1, it takes from the Laplace smoothing formula, at1 formula. So 3 plus 1 divided by 3 plus 2. And for Japan, it is not there in the China class. You can see here, there is non-occurrences of the term Japan in the China class. So it is 0 here. 0 plus 1 is for at1 smoothing. This 1 is for at1 smoothing. And 3 plus 2 already I have explained here. 3 for 3 documents in C and 1 document in CDS. CDS is no class. Then the other calculations are same. Okay, only this denominator value is different. Other classification will be similar. So with this value, little difference is there with the previous calculation. So here we get on finding the score of the test document. For D5 in C, we get around 0.005. And for D5 in CDS, we get around 0.022. Okay, 0.022. And also while finding the conditional probability here, we will be multiplying with this value is like this. Okay. So you can see this formula with this is the prior probability, this is the conditional probability, this is conditional probability, this is conditional probability. And also in Bernoulli's model, we are going to find for the non-occurrences of the term also. Non-occurrences means Beijing is not there in the test document. Here you can see Chinese, 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 Tokyo, Japan. There is no Beijing here. But while finding the score, we are going to multiply this value also. That's why here 1 minus probability of conditional probability of Bayesian in China class. So that means we are going to find the conditional probability for all the terms here. Okay. So you have to know the difference between Bayes classification and Bernoulli's classification. In Bayes classification, we are finding only the uh, terms in the test document. But here in Bernoulli's model, we are going to find for all the terms. Okay. But while finding the score, what we are going to do is we will be using this 1 minus probability of Bayesian, conditional probability of Bayesian in China class. Because 1 minus, because this is a non-occurrence term. Non-occurrence term in the test document. That's why 1 minus this Bayesian, conditional probability of Bayesian. Similarly, 1 minus conditional probability of Shanghai and conditional 1 minus conditional probability of Macau. So after finding the conditional probabilities of all the values and substituting in this formula, we are finding the value of D5, that is the score of D5 in C class. So similarly, we are again calculating D5 in C class. So same here also, 1 minus 1 by 3, this comes from these conditional probabilities of Beijing, Shanghai, and Macau. So after calculation, we got 0.022. So the two scores are given here. So we have two different scores here. The initial one was using Bayes classification. The second one now we are doing is using Bernoulli's classification. So here, as you see the probability values, in this case, the second probability has a higher probability value comparatively with the D5 in C. So the classifier will assign the test document to North China class. Okay. Initially, using Bayes, the classifier assigns this particular test document to China class, but here in this second method using Bernoulli's method, the classifier assigns the test document to North China class. That's why we compute an evaluation for the performance. Sometimes the classifier assigns to China class, sometimes the classifier assigns to not China class based on their this calculation on probabilities. So for the second method, the classifier assigns a test document to China class. That's why we are computing the evaluation for performance. So performance parameters we will be calculating, the accuracy we will be calculating, and we can choose the better method. That if the method which has higher accuracy, you can choose that method. Okay, but you have to know all these methods: Bayes classification also, Bernoulli's classification also. So here, one more point in this: when looking at the binary occurrence and not at the term frequency, so Japan and Tokyo, they are the indicators for not China class, right? And the conditional probabilities for Chinese, they are for in China and not China class, they also have different values. So this will surely affect the classification, right? So in Bayes classification, this value itself it is different. Now in Bernoulli's classification, so the method here, so we got different values here. So conditional probability values will be different in comparison with the Bayes classification. So Bernoulli's classification will have different conditional probability values with comparison to your the first method, Bayes classification method. So the probabilities will be different. That's why we got different probability values here and different classes we got here. Now, next one. So multinomial Bayes model. Multinomial. One second. So multinomial, here you can see this is for Bayes and the second one is for Bernoulli. So for China class, we have Bayesian, we have N, we have this one different. This China class will have different terms here. So Bayesian and Taipei, join, WTO. So these are examples, like it can have different other terms also in the same class. And in Bernoulli, it will be representing in a binary independence model, like zeros and ones. Here it will be terms, here it will be zeros and ones. So just to show the difference, I'm just showing this diagram here. These are the terms, Beijing and Taipei join WTO. And here in Bernoulli, you can see here, Alaska 0, Beijing 1. This means Alaska is not present in the China class. Beijing is present in the China class. India is not present in the China class. Join is present in China class. Taipei is present in China class. WTO is present in China class. Like this. Okay. Okay. One second. Next one, I think up to this, I think this is your end of the chapter number 7. Okay, all the classic probability models. So all those what we have discussed today and in the last class, these are for probability models. So in next class, we will see one second. Oh, one more classification is there, Rocchio's classification. Rocchio's classification, one second. So this is so this classification we will see in next class, but let us just see a brief explanation about this vector space classification. So this one, so we have two vector space classification method, Rocchio and KNN. This method we will see in next class. One second. So here also we can take the same example and calculation only will be different here. Okay, so you can give your attendance, roll number 1. 2,
Present, ma'am.